Hello dear student, see in this lecture we are going to see heterocyclic dyes, 6 class of dye, that is heterocyclic dyes. Now see, these dyes, heterocyclic dyes, are further classified. These heterocyclic dyes are further classified into different categories based on which heterocyclic ring is present. Okay, so these are classified on the basis of which heterocyclic ring is present. So see, these dyes are classified into what? Thiazine dyes, then these dyes is further classified into second category is Azine dyes, third one is Xanthine dyes, fourth one is Oxazine, okay, Oxazine dyes, and fifth one is Acridine dyes. Fifth one is what? Acridine dyes. So first one is what? Thiazine dyes, second one is Azine, third one is what? Xanthine, fourth one is Oxazine dyes, and fifth one is Acridine dyes. Okay, so these dyes are having different type of heteroatom in their structure. These dyes, okay, all these dyes are having what? Different type of heteroatom in their structure. That heteroatom, if it is linked with carbon-carbon double bond, that type of grouping, okay, that heteroatom, or it may link with what? Carbon-carbon double bond, that type of grouping, it act as a chromophore. It act as a chromophore in these dyes, okay. And oxochrome, it may be a amino group, it may be a hydroxyl group, okay. So that amino or a hydroxyl group, they will act as a oxochrome in the structure of these dyes. Now in this lecture we are going to see thiazine dyes and azine dyes. Thiazine dyes and azine dyes. See, thiazine dyes are having a example of okay, this is what? A phenothiazine. Phenothiazine. This is what? A phenothiazine nucleus, and these thiazine dyes is having what? Phenothiazine nucleus, and that phenothiazine molecule will see NS, okay, it's a like a what? Your anthracene, but one carbon is replaced by nitrogen and second carbon is replaced by sulfur, okay. So this is what? A phenothiazine. Now example of this thiazine dyes is okay, see there is a what? Substituent, this NMe2 substituent which is present at this position, okay. And these dyes, the name of this example is methylene blue. Methylene blue. Name of this example is what? Methylene blue. See, this methylene blue dye, or you may say phenothiazine dyes, okay, or we may say thiazine dyes, okay. Thiazine dyes or phenothiazine, or example is what? Methylene blue. These dyes are used for dyeing paper, okay. These dyes are used for what? Dyeing paper. They are used for dyeing wool and silk, okay. They are used for dyeing wool and silk also, and these dyes are also used for dyeing tannin, mordanted cotton. These dyes are also used for dyeing tannin mordanted cotton. We know cotton, okay. So Tannin is what? A mordant. Tannin is what? A mordant. So tannin mordanted cotton. Okay, so this dye is used for dyeing tannin mordanted cotton, dyeing wool and silk. It is also used for dyeing paper. So these are the use of what? Thiazine dyes. These are the use of what? Thiazine dyes. This is what the basic core structure of phenothiazine, which is belongs to what? Thiazine dyes. Okay, so this phenothiazine structure, this basic core structure will act as a chromophore, while here NMe2 group will act as a oxochrome in the example of methylene blue. So this is what a example of methylene blue. You know, methylene blue is also used as a indicator. Okay, so this is what? Thiazine dyes. Now we will see second class of dye, azine dyes. Second class of dye is what? Azine dyes. Okay, let us see. See, azine dyes are having structure. Azine dyes are having a structure. See here, I forgot to write in methylene blue Cl minus. Okay, you may write S plus Cl minus here. S plus Cl minus, that is what your methylene blue. Now see, in azine dyes, example is what? This is phenazine. Okay, phenazine. This is what your azine dyes. Okay, this is what your azine dyes. Example of azine dye is what? Phenazine. Now phenazine is not an example. Phenazine is a what? Basic core structure. Okay, phenazine is what? A basic core structure of azine dyes. Now these phenazine dyes, that is azine dyes, are having an example. Azine dyes are having an example. See, okay, N plus pH, safranine tea, safranine tea. This is what a example of azine dye. This is what a example of azine dye, safranine tea. Okay, now we have to see synthesis of this safranine tea. Synthesis of what? Safranine tea. Okay, so azine dye is having basic core structure. Okay, 2 nitrogen atom are here. 2 nitrogen atom are here in the what? Form of, you may say, anthracene. Okay, anthracene CH2 CH are replaced by 9 and 10, the CH which is at 9 and 10 carbon atom. Okay, that are replaced by 2 nitrogen atom. So we will get what? Phenazine. Okay, this is what a basic core structure of azine dye, and that will act as a chromophore. Now here NH2 and methyl group will act as a what? Oxochromes. Okay, in what? Safranine tea. So safranine tea is belongs to what? Azine dyes. Safranine tea is belongs to what? Azine dyes. While methylene blue is belongs to what? Phenothiazine dyes or thiazine dyes. Okay, now let us see synthesis of the safranine tea. Okay, let us see synthesis. Synthesis of safranine tea. Synthesis of what? Safranine tea. See, this synthesis is belongs to, it start with reaction of orthotoluidine. What is it? Orthotoluidine. So first step is, in the synthesis of safranine tea, first step is what? Step 1. Synthesis of 2,5-diamino-toluene. Okay, synthesis of 2,5-diamino-toluene. So we have to synthesize 2,5-diamino-toluene in step 1 from what? Orthotoluidine, isn't it? So orthotoluidine is reacted with sodium nitrite hydrochloric acid at 0 degree Celsius, sodium nitrite hydrochloric acid at 0 degree Celsius. So you know there will be a what? Diazotization. There will be a what? Diazotization will take place. So we will have N triple bond N Cl. So this diazonium salt it will form. Now this diazonium salt, okay, it is on reaction with again orthoaminotoluene. This diazonium salt, I am removing out this structure, okay. So this diazonium salt is on reaction with (2,5-diaminotoluene), sorry, is on reaction with again orthotoluidine. So there will be what? A coupling. There will be what? A coupling reaction. So we will get a coupled product. So which product we will get? See, I will write it in more proper way. So I will get the place there. This is what? Orthotoluidine. Okay, so this orthotoluidine is going to couple with para position, at this para position with respect to this amino group. Coupling. So what we will get? We will get a this type of coupled derivative. And double bond N CH3. So there is what? CH3 here, and there is NH2 here. Okay, don't forget there is what? NH2 at this position. Now this what? We will get a coupled product here. What is this? Coupling product. Now this coupling product is on reaction with iron HCl, okay, reducing reagent, iron HCl, hydrochloric acid. So there will be what? Reduction at this place. So it will be a reductive cleavage, okay, it will be a what? Reductive cleavage. So what we will get? See, we will get, it is what? A reductive cleavage. So you will get CH3 NH2, you will get again orthotoluidine back, 1 mole of orthotoluidine back, and second product will be what? NH2 this is what? CH3, and this is what? Amino. Okay, so it is 1, 2, 3, 4, 5, 6. So it is what? 2,5-diaminotoluene. So it is what? 2,5-diaminotoluene. So in this way we have synthesized 2,5-diaminotoluene from what? Orthotoluidine. Okay, from what? Orthotoluidine. So this is what? Step 1, synthesis of 2,5-diaminotoluene. Now Segi, next step is what? Step 2. Step 2, conversion, that is conversion of 2,5-diaminotoluene into Safranine T. Into what? Safranine T. Conversion of 2,5-diaminotoluene into what? Safranine T. Now see, write 2,5-diaminotoluene in proper fashion. So we can write the synthesis in proper way. Okay, so this is carbon number 1, sorry, carbon number 1, 2, 3, 4, 5. It's what a 2,5-diaminotoluene. 2,5-diaminotoluene. Now this 2,5-diaminotoluene is reacted with orthotoluidine. It is reacted again with what? Orthotoluidine, NH2 CH3. So you will have C hydrogen. Now there will be a what? Oxidation. There will be what? Oxidation by using sodium dichromate. By using what? Sodium dichromate, and followed by reaction with hydrochloric acid, and there will be a loss of water molecule. So there will be a what? Oxidation, okay, oxidative coupling here. There will be what? Oxidative coupling. So these NH2 and this carbon, okay, they will couple with each other. So what we will get? See, we will get a indamine. What we will get? The name of intermediate will be a indamine. Name of intermediate is what? A indamine. C, as we are using hydrochloric acid, so as we have written hydrochloric acid, so hence we have to write a final product here. Final product, that means final product of this step. So this is what? A indamine. Here you will have NH2 plus Cl minus. Okay, it's a indamine. What is it? Indamine. So this what intermediate we will get from this step by the reaction of 2,5-diaminotoluene with orthotoluidine. Okay, this is what? A orthotoluidine. So both of them will couple through what? Oxidative coupling in presence of sodium dichromate. So what we will get. Now in next step, this compound is on reaction with what? Aniline. Okay, this compound is on reaction with what? Aniline. This compound is on reaction with aniline. Okay, so aniline will attack at this carbon, that is most electrophilic, to neutralize the positive charge of this NH2, isn't it? So what we will get? See, in next step we will get structure like this. Okay, see, I am writing structure here, okay, as there is a place. So what we will get? NH2, this will be CH3, NHPH. I am writing directly NHPH. I am showing there is what? Loss of proton. Okay, so here it will be a NHPH. So this what you will get in this step. This what the intermediate you will get in this step. Okay, now see this intermediate will tautomerize. There will be what? Tautomeric hydrogen. So you will get NH here. Okay, there will be a what? NH, conversion into NH. Now what you will get? See, you will get next intermediate like this. Okay, see, this is going to this is going to this, NH2CH3. So there will be what? Complete aromatization of this ring will take place. So we are getting like this structure, like this intermediate, like this NH pH. Okay, see, I am showing this hydrogen here. Now see, in next step, this hydrogen, okay, there will be what? Loss of that two hydrogen in presence of, I am writing here, that is in presence of again sodium dichromate, Na2Cr2O7 oxidation. Okay, first is what? Sodium dichromate. Second one is hydrochloric acid. Second one is what? Hydrochloric acid, use of hydrochloric acid. And there will be what? Loss of water molecule. Now what we will get? See, we will get the structure like this. Okay, there is what? A oxidation. So we are getting structure like this. CH3 NH2 NPH. NH2. See, here we are using what? Hydrochloric acid. So it will get converted into salt. It will get converted into corresponding salt. So we will have structure like this, NH2 plus. Okay, we will get structure like this, NH2 plus Cl minus. So this is what? A safranine T. This is what? Safranine T. Now we can write a resonating structure for this safranine T. We can write a resonating structure for this safranine T like this. Okay. So we will have a next resonating structure. See, these are two are what? Resonating structure, hence I am showing arrow like this. See here, I forgot to write methyl. So methyl is here. NPH Cl minus. So this is what? A another resonating structure of safranine T. You may write this or you may write this. Okay, both are what? Safranine T. So this is what? A synthesis of safranine T. Once again I am repeating it. See, in the synthesis of safranine T, Orthotoluidine. First step is what? We have to convert orthotoluidine into what? 2,5-diaminotoluene. Synthesis of 2,5-diaminotoluene. This what we have to carry out first. So orthotoluidine is reacted with sodium nitrite hydrochloric acid to get what? A diazonium salt. Now that diazonium salt is coupled with what? Again second mole of orthotoluidine to get a coupling product. Now that coupling product is reduced, okay, by using what? Iron HCl. So that will be a what? Reductive cleavage. This bond will reduce also and it will get cleaved also. So what you will get? You will get this orthotoluidine and you will get what? 2,5-diaminotoluene. Okay, so this nitrogen will get converted into NH2. This nitrogen will also get converted into NH2. Now this what we will get? Now second step conversion into what? Safranine T. So 2,5-diaminotoluene is reacted with what? Orthotoluidine back. Okay, it is reacted. 2,5-diaminotoluene is reacted with what? Orthotoluidine in presence of oxidizing reagent like sodium dichromate. Okay, so there will be what? Oxidative coupling. Two ring will get coupled. We will get this intermediate. Now this intermediate is called indamine. That is on reaction with aniline. We will get this intermediate. Now this intermediate is on reaction. So there will be what? Just tautomerization. So we will get this intermediate, and that intermediate is on oxidative coupling again with sodium dichromate. We will get this safranine T, and for this safranine T we can write a resonating structure. Okay, that is what? Second form of safranine T. Now what is the use of this safranine T? Okay, what is the use of this safranine T? This safranine T is a red dye, red heterocyclic dye. It is used for dyeing paper also. It is used for dyeing cotton, silk, wool. Okay, but it is used for tannin mordanted cotton. It is used for what? Which type of cotton? Tannin mordanted cotton. Okay, we cannot use direct cotton. Okay, pure form of cotton. So we have to use this dye for tannin mordanted cotton. Okay, see this class of dye, that is a Methylene. It's what? A Thiazine class of dye. It belongs to what? A that is this is safranine T. Okay, so if you remember in last semester we have seen in first chapter a dye Methylene. Okay, this Methylene dye is also belongs to this Thiazine class. This Methylene dye is also belongs to what? Azine class, and it was synthesized by Perkin. Okay, it was synthesized by a Perkin. That was the first synthetic dye. This was what? This Methylene dye was the first synthetic dye. This Methylene dye is also belongs to same class of safranine T, that is Azine dye. Okay, so this safranine T is also used as a staining reagent. It is also used as a staining reagent in for staining of various microorganisms. Okay, it is also used as a staining reagent or a staining agent for various microorganisms in biological laboratories. Okay, so this was what the use of safranine T, and this was what the use of this was what the synthesis of safranine T. Okay, we will stop here. I hope you have understood this topic. We'll stop here. Thank you.